Spud. Tater.
Potato.
So, if it isn't already obvious, for our Boy Who Harnessed the Wind project, our project mainly revolves around potatoes, specifically potato power. Our group set out to answer one question: can potatoes power clocks? Through some trial and error, we discovered that potatoes can power a clock, why they can, and the purpose in such a power, and some other fun facts along the way.
So we took a video of our potato and how we put it together
We're going to be creating a potato-powered clock. In order to do this, you need 2 potatoes, 2 galvanized nails, 2 copper wires, a thinner copper wire, and if your digital clock does not already have copper wires attached, you will also need 2 others. First, to start, you want to take your copper wire and stick it into your potato as far as you can, but you don't want to get it into the other side. Then you take the plated nail and also stick it into the other potato. You should have these 2 connected with a copper wire. Then you take your galvanized nail and stick it into this potato. You want to make sure that you have a copper wire and a galvanized nail in one potato. You do not want 2 copper wires in one potato. Then you take your other copper wire and stick it in the potato. You need to make sure that your wire is attached from the copper wire to the clock and from the nail to the clock. This should be able to power your clock.
After seeing our work in action, you might be wondering how exactly it works. Believe it or not, it's actually pretty simple. When the piece is set up, it acts similar to that of a battery. The copper wire that is stuck into the potato acts like a cathode, or the positive charge. The potatoes act as electrolytes, or the conductor, and the zinc-plated nails act as the anode, or the negative charge.
The battery we created also creates an electrical circuit due to the contraption. This contraption obviously creates that electrical current when it's attached to the clock. That allows the electricity to flow through it. You have the potato connected to the nail, and that's how it works.
Moving on to the energy side of things, we started out with chemical potential energy from the potatoes. Then it's transferred into kinetic chemical energy, and finally into kinetic electrical energy.
This whole potato power thing is great and all, but what is the point? In remote parts and poor parts of the world, things like batteries are a privilege. For people in these areas, they can be either hard to get a hold of, expensive, or both. The supplies needed to create this battery for people like them are more likely to get a hold of than others.
You might think it's a waste of food, but when the battery finally dies, you just pull out the copper wire and the nail, and then you just stick it in another part of the potato. You can use it for multiple times, and it lasts for quite some time, so it's not really a waste when you can use it for, I'm guessing, months at a time.
Throughout our testing, we discovered that not only potatoes work. We found that carrots, oranges, water, and even the human body allow electrical current to flow. From this, we concluded that anything containing moisture that could be contained in one space would allow electrical current to flow with this particular experiment.
To summarize, we discovered that our potatoes sign does in fact work. That it is similar to that of a battery, provides an electricity source to others, and works with materials other than potatoes.
Hope you all have a spectacular day.